Today, we're going to connect two worlds you probably never thought belonged in the same sentence: the classic HP programmable calculators and the very future of artificial intelligence. And trust me, the connection is fascinating. So, this is for anyone out there who has an HP 49G or maybe the legendary HP 50G. You've got this incredible piece of engineering, but let me ask you, are you still running it in the default algebraic mode? Like any other basic calculator you'd find in a classroom? If you are, hey, you're not alone, but you are missing out on its real power. The whole inspiration for this explainer comes from the amazing work of Professor Linares. His YouTube channel is an absolute goldmine for HP fans. And he had this philosophy. It's all about sharing knowledge freely, turning it into a conversation between him, the calculator, and you. And in that spirit, we're going to borrow a term that he coined because it is just perfect. He calls it dead brain mode, and it's exactly what it sounds like. It's when you have this powerful machine built for a way of thinking called reverse Polish notation, but you leave it in its factory default algebraic state. All the flags are untouched, the beeps are still on, and the revolutionary heart of the machine, the stack, is completely invisible. It's like you own a race car, but you're just stuck driving it in first gear. So, how do we get out of first gear? Well, we have to switch from dead brain mode to what we're going to call living stack mode. And it all starts by embracing the way these amazing calculators were actually meant to think. So on one side, you have algebraic mode. You type in a long equation, you hit enter, and poof, a magic answer appears. All the steps in between are totally hidden. It's opaque. But on the other side, you have RPN, reverse Polish notation. Here, there's no equals key. Instead, you've got this visible stack of numbers, and you directly manipulate them. It's transparent. It feels less like you're just punching buttons and more like you're actually sculpting the solution right in front of your eyes. And you do this sculpting with just a few simple, powerful operations. Enter pushes data onto the stack. Drop gets rid of something. Swap and roll let you move things around. The point is, you are in complete control of the whole workflow, seeing every single intermediate value as you build up to the final answer. Let's just watch this in action. Say we want to do a simple calculation, like 37 plus 72. First, we push our first number onto the empty stack, so 37, then enter. And there it is, 37 is now living on the stack. Next, we push our second number, so 72, then enter. See that? Now both numbers are on the stack, ready to go. We've given it the data first, now we give it the operation. We just hit the plus key. And bam, there's our answer. The plus operation grabbed the top two numbers, added them, and placed the result right back on the stack. Every single step was visible. For an engineer solving a nasty complex number problem, that transparency isn't just nice, it's everything. This is living stack mode. Okay, cool. That's a neat trip down memory lane for calculator nerds, but what on earth does any of this have to do with cutting-edge AI? Well, this is where the analogy gets really powerful. That difference, between the opaque, magic answer, algebraic mode, and the transparent, step-by-step RPN mode, it turns out to be one of the best ways to understand a massive divide in how people are building AI today. Think about the AI that dominates the headlines, right? Especially the big large language models. They're what we call black boxes. We give them a prompt, they spit out an answer. But the reasoning, the actual path from A to B, is completely hidden inside this giant statistical soup of billions of numbers. When it makes a mistake, trying to figure out why it's just pure guesswork. So here's the core idea, the big takeaway. Right now, we are running the most powerful processors on the entire planet, our GPUs, in what is basically dead brain mode. We're using their incredible muscle for number crunching, but we're keeping their entire reasoning process completely hidden. We're using them in algebraic mode. But what if there was another way? What if we could actually build an AI that runs its GPU in living stock mode? This is where we can talk about an alternative architecture, a project called K3D. To really get what K3D is trying to do, start with this mental picture. Imagine you're building an AI, but instead of a black box neural net, you're basically giving it the mind of an HP 50G. Except it doesn't just get a simple linear stack. It gets a whole three-dimensional workspace, a house of memories, where it can lay out problems and solutions spatially. And look, this is not just a cute analogy. K3D's core engine, the part that runs right on the GPU, is a literal RPN engine. It uses explicit opcodes, just like a low-level programming language. This means the AI's thoughts are actual programs, with commands for matrix math, sure, but also for if-then logic, for loops, and for storing and recalling variables. It's actual programming, not just statistical guesswork. So this architecture has three main pieces. You've got the cranium, that's the RPN engine where the step-by-step thinking happens. Then you have the house, that's the active memory, a 3D workspace that's kind of like a virtual lab bench. And finally, the galaxy is the long-term memory, where proven concepts and useful programs are stored, like a massive library of functions. It's a stack that grows in 3 dimensions. Okay, so why am I bringing all this up in a talk that started with calculators? It's because the philosophy that makes you a dedicated RPN user, that is the exact philosophy that is so desperately needed in AI development today. If you're an RPN fan, you get this in your bones. You choose the stack, not just because it's different, but because it gives you clarity, it gives you control, and it gives you a deep understanding of what's actually happening. You value seeing the work. You don't trust black boxes when you're solving a critical problem. And that brings us to the real heart of it all. Just think about it for a second. If you were up against a nasty Laplace transform for a circuit problem, would you ever choose the opaque algebraic mode when you have a beautiful, transparent RPN stack ready to go? No way. So why are we so quick to accept this ALG mode for artificial intelligence, where the stakes are infinitely higher? See, this isn't just about building a different kind of AI. It's about building a future that we can actually understand, a future we can inspect, and a future we can debug. It's about choosing transparency over opacity. And this push for transparency isn't new. It has a rich, beautiful history, rooted in this idea of creating objects to think with. It connects pioneers like Seymour Papert, who gave kids the Logo turtle to make geometry tangible, and Marvin Minsky, whose frames tried to structure knowledge explicitly. The HP stack and K3D's spatial worlds, they're direct descendants of this incredibly powerful idea. So we'll end on this. A huge thank you again to Professor Linares for his incredible teaching and for giving us the perfect term, dead brain mode. If we care enough to take our own calculators out of it, to unlock their true potential by embracing the living stack, then maybe it's time we demand the exact same thing from our artificial intelligence. It's time to build AI systems whose reasoning, whose stacks and worlds we can actually see, understand, and debug together.